dear friends, today we are going to study a discrete mathematics subject. Discrete mathematics subject. So we need here first to understand what is by discrete mathematics. Okay, so discrete mathematics of a mathematics involving discrete element that uses algebra and arithmetic. So discrete mathematics it is a branch which contains discrete element and that were using the algebra and arithmetics. So these types of operations which are performed on the discrete elements. Okay, so now the mathematics which are divided into two types. First is continuous mathematics. First, continuous mathematics, and second is a discrete mathematics. So first we need to here first to understand what is by continuous mathematics. It is based upon continuous number of line or real numbers. Means suppose this is a line. Here we need to provide first starting point and end point to the system, and we can draw a number of the pixels between all the starting points and end points, and to draw a smooth line. Means this is a continuous line. Okay, so this is an example of continuous mathematics. But in discrete mathematics it involves a different values. So we cannot draw a continuous object in a discrete mathematics. Okay, so that is between any 2 points there are the countable number of points. For example, if we have a finite set of objects, the function can be defined as a list of order pair having these objects. Means suppose set A, which is contains 1, 4, 8, 9. So this type of different types of object. Okay, so it is not a continuous. Means so we can this is unordered elements, means 9, 1, 4, okay, and 2. So this is a example of a discrete mathematics. Okay, so next thing here we need to we are going to study a first unit. Before starting the first unit, we need to first understand the structure of a discrete mathematics. So total marks for a discrete mathematics 100 marks. So there are first is in same exam for a 30 marks, and second is theory exam and same exam for 70 marks. Total 100 marks paper. Total 100 marks for a discrete mathematics. Okay, so the discrete mathematics which contains there are total 6 units. First unit is set theory and logic. Now here we need to first understand what is by set theory. First understand what is by set. So set is an unordered collection of different elements. Unordered is an unordered collection of different elements. Okay, so unordered of different elements means it contains a distinct elements which are not a same elements in a one set. Okay, so a set can be written explicitly by listing its element using the set bracket. Okay, suppose for example A equals to 1 2 3 4 bracket complete, braces complete. So this is a set. Okay, if the order of the elements is changed or any element of a set is repeated, it does not make any change in the set. If we want to change the order and if we want to repeat the elements in a set, so we cannot be changed in the set. For example of a set of all positive integers. Example, a set of all positive integer. Okay. Second example, a set of all states in India. A set of all the states in India. Third example is a set of all the lowercase letter of the alphabet. A set of all the lowercase a set of all the lowercase letter in alphabet. Okay, so all these are the examples of a set. So next, the representation of a set. Next topic is representation of set. Representation of a set. So we have already studied what is by set, and second topic is representation of set. How to represent these sets? So we can represent this set in two ways. First way is tabular form. And second is builder form. Okay, so these are the, by using these two ways we can represent the set. So first study or understand the tabular form. What is by tabular form? How to represent the sets in tabular form. Okay, so first form is tabular form. Okay, so what is by tabular form? A set is represented by listing all the elements in comprising it. Okay, the elements are enclosed within the braces and separated by commas. Okay, the set is represented by listing all the elements comprising it, and the elements are enclosed within braces and separated by commas. For example, first, set of ovals in English alphabet. Okay, in English alphabet. Second is English alphabet means A. For example, A equals to A, E, I, O, U. So total 5 vowels in a alphabets. English alphabets means tabular form is set of all vowels in English alphabet. So this set is A, E, I, O, U. All these are elements which are separated by using the comma and which are enclosed under the braces, curly braces. Okay. Next, second example is set of odd numbers less than 10. Second example is set of odd numbers less than 10, means the set which contain the numbers or numbers which are less than 10. Suppose the set name is A. So here first odd number is 1, okay, less than 10. Second odd number third which is less than 10, okay. 5 less than 10. Next number 7 less than 10. Next 9 less than 10. 10 not a even number. So 11 which are greater than 10 means so total 5 numbers which are odd and less than 10. So all these are odd numbers which are satisfied the condition which are less than 10. Okay, so this set A, which is collection of a odd numbers which are less than 10. So this form, so all these are elements were considered here, and all these are elements separated by comma and closed under the curly braces. So in this form of we can represent the set in tabular form. Okay, this is a tabular form. So next is builder form. Second type is builder form. Okay, so builder form. What is by builder form? A set is defined by specifying a property that element of the set have in common. So means the set which contains the specified element property, the element property which are used here, and so all the elements which are in the set have a similar property. Okay, so first what is by property? Okay, for example, first the set example first for builder form. So a set, this set A E I O U, this is a tabular form representation of a set and is written as builder form. So how to written this tabular form set represented in builder form? A, which is a set which contain X such that, which contain element X such that X is a vowel in English alphabet, okay, curly braces here. So A, which is a set which contain the X element such that X is a vowel in English alphabets. Okay, this is a builder form of representation of this set, and this is a tabular form of a set. Okay, so builder form means descriptive form. It is also called a descriptive form. Suppose for example, here the set contains even numbers, means 0, 1, which are less than, the set which contains the even numbers which are less than 5, means there are total 4 elements which are even even numbers which are less than 5. So how to represent this form, tabular form, in builder form? The set A contains x elements such that x is an even number and less than x less than 5, and x less than 5 means the set A contains x such elements if the element x satisfies the both condition, x is an even number and x less than 5. So if the elements which satisfy both conditions, those elements which are included in element set A. So first 0 which is the even number and which is also less than 5 means 0. Okay, second, sorry, here one is not here because which are odd number 0 to 4. Okay, next number 1 is odd. Okay, second 2 is even number and also less than 5 means here 2. Next 3 is odd number which is not a even number. Next 4 which is a even number and less than 5, so write down here 4. Next 5 which is a odd number and okay. Next 6 is a even number but greater than 5 means that the number which is not satisfy the second condition, means the set A which is contains the total 3 elements which are satisfy this condition, both conditions. Okay, so this is a builder form and this is a tabular form representation of a set. Are you understanding? If any doubts, if you are not getting clear the concept, so that's times we can message me, we can comment me, and I will solve all this. I will clear all the concept or the issues you are getting. Okay, so next I will clear your things. Next, there are some standards. Means first we need to understand if the element x is a member of any set. Yes, suppose x is a member of set yes. Okay, so S is a member of set S means the x which are in a set X. So how to denote the x in set S? So x belongs to S means x belongs to X means S means it is a member of a set S. Okay, and if the element Y is not a member of set S means Y which not belongs to S means how to denote the Y not belongs to S. We can denote the if the member Y which is not a member of S, we can denote by using these symbols. Not belongs to S and belongs to X which we can use this symbol belongs to S. Okay, are you getting? Next topic is cardinality of a set. Cardinality of a set. So what is by cardinality of a set? What is by cardinality of a set? Cardinality of set. Cardinality of set. So cardinality of a set yes denoted by cardinality of set yes denoted by capital yes. So what do you, by using mod yes, by using yes. Okay, is the number of elements of a set. Cardinality means total number of elements in set S. Number of elements of the set S, capital S. Okay, means total number of elements are in set. This is the cardinality of given set S. By using, to denote the cardinality of set by using this notation. Okay, so next one important point is, if the set has an infinite number of elements, because we can calculate the cardinality of a finite set. Okay, we can easily count how many members, how many elements in a particular set. But if the set has an infinite number of elements, so its cardinality is infinity. Set cardinality S equals to infinity. Okay, by using this notation, infinity. Cardinality of infinite set is infinity. Okay, next, for example, suppose the set 1, 4, 3, 5. Okay, so total how many elements in a set? Given set there are 4, means cardinality is 4. Okay, we can also define this set. Suppose A equals to 1, 2, 3, 4, 5. Okay, so cardinality of set A means, by using this notation, cardinality of A equals to 5. Total how many members in a set A? 5, means this is the cardinality of set, given set A is 5. Okay, if this set is infinite, suppose A equals to 1, 2, 3, 4. A, which is a set of natural numbers. A is a set of natural numbers. So cardinality of infinite set A equals to infinity. A equals to infinity. So we cannot count the total how many numbers in a given set, infinite set. Okay, so next thing is, next topic is a types of sets. Next topic is types of set. Okay, so in this topic we need to first understand the basic types of a set. Okay, so total how many types of set? First is finite set. Okay, first is finite set. Second is infinite set. Next, third is subset. Fourth is proper subset. Fifth is universal set. And sixth is a empty set or null set. And seventh is singleton set. Singleton set or unit set. Okay, next, 8 equal set. 9 equivalent set. Next set is power set. set. Next set is 10 number power set. All these are the basic set. Next, bounded set, unbounded set, countable set, uncountable set. Okay, so all these are the sets, but today we will understand these are the basic sets, types of sets. First is a finite set. Okay, first set type is a finite set. So what is a finite set? Finite set is a set which contains the finite number of elements, is called as finite set. Okay, first set is finite set. First type is finite set, which contain finite elements, is called as finite set. Finite elements means limited number of elements. Okay, for example first, yes, the set yes which contain x elements such that x belongs to n. And second condition, x less than 70 greater than 50, curly braces. So here set which contain x elements such that x belongs to n and x greater than 70, less than 70 and greater than 50. Okay, so n means natural number, x which belongs to natural numbers. Okay, which are belongs to natural number set. Okay, so total how many elements the set x yes contain? So first, greater than 50. Okay, so a natural number means 50, 51, next 52, 53, 54, 55, 56, 57, 58, up to less than 70. Okay, 59, 60, 1, 2, 3, 4, 5, 6, 67, 68, 69. Because here less than 70 not equals to less than equals to 70. Okay, so total how many elements? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So total how many elements? 20 elements. We can easily count. Means this set contains the finite number of elements. We can easily count the total how many elements the set S contains. So that's why this set is called as finite set, because which contain the finite number of elements or numbers. Okay, so next set is infinite set. Next set is infinite set. Infinite set. Okay, so infinite set, a set which contain infinite number of elements. Infinite number of elements which is called as infinite set. For example, infinite number set means we can count the number how many elements in a set is called as uncountable set, means it is called as infinite set. Okay, so the first example, yes, a set yes which contain x elements such that x belongs to n means x which are belongs to natural number set and x greater than 10. X greater than 10. Okay, so total how many elements? X such that x belongs to n and x greater than 10. 1 0, sorry, first starting with 0. 0 is less than 10, but here x is greater than 10. 1 less than 2 up to 9 less than 10 equals to, but here condition is x is greater than 10, not a equals to 10. Okay, so that's why 11 12 13 14 15 up so on. So here we cannot count the total number how many elements in yes. So this type of set is called as infinite set. Are you getting? This type of set is called as infinite set. Okay. So, next topic is subset. Next set is subset. Next set is subset. Okay. A set is X is a subset of set Y. Okay. First thing, a set X is a subset of set Y. So how to denote this set X which are the subset of Y? We can denote by using this symbol X subset of Y. Using this symbol by subset which are denoted by this symbol. Okay, so what is by subset? X is subset, for example, X is subset of Y means all the elements of X which are in Y. If the every element of X is an element of Y. Okay, so for example, suppose example X, let X which contains 1 2. So set X which contains there are two numbers. Okay, and Y set which contains 1 2 3 4 5. Okay, the Y set which contains total 5 elements. That's why all the elements of X means 1 and 2 which are in set Y means 1 2 which are also in Y. Okay, all the elements of X which are in Y means that's why X which is a subset of Y. X which is a subset of Y. Okay, so second example, suppose X contains A, B, C, okay, and Y contains only A. Suppose, okay, here X contains how many elements? There are 3 elements, and Y which is contains 1 element only. Okay, so all the elements of X which are contains in Y not only contains 1 elements, A elements, not a all elements, means X which is not a subset of a Y, but Y contains only single elements which are also in X set. Okay, so all the elements of Y which are in X, that's why Y which is a subset of X. Okay, but Y X which is not a subset of Y by using this symbol. By using this symbol, X which are not a subset of Y, which are not a subset of Y. Okay, so this is a example of a subset. Next set is a proper subset. Next subset is a proper subset. proper subset. Okay, what is by proper subset? A term proper subset can be defined as subset of but not equal to a set X. For example, set X is a proper subset of Y. So how to denote? X subset proper subset Y. X proper subset of Y. If the every element of X, every element of set X is an element of Y, is an element of Y, but at least one element, one or more elements of Y, means for example, suppose X which is contains 1 2 3 4 5 6, X set which contains 1 2 3 4 5 6, and Y which is contains 1 2. Okay, so the Y set which is contains 1 2 and X set which is contains 1 2, the total 6 elements. But all the elements of Y which are in X set, but at least one or more elements which are in set X, means here 1 2. Okay, but here there are 4 elements which are not in A. That's why Y which is a proper subset of X, which is called a Y is a proper subset of X. Okay, so here Y is proper subset of X since all the elements in Y are contained in X. All the elements in Y are contained in X. 2 and X has at least one element is more than set Y. At least one element more than set Y. So that's why Y is a proper subset of X. Okay, thank you.